Yeah. So I guess if it was back in 2013, it was like 7 years ago, or maybe a little over 7 years ago now, that I met Mustafa actually probably around this time of year. But I remember like up until the point where I met Mustafa, I was using a lot of different types of tools to try and model buildings and educate myself about modeling buildings. But I was constantly finding myself like hitting a wall of, not being able to test a certain like, cool, innovative strategy that I came up with that I wanted to see if it would actually work, and I kept hitting these walls a lot of the times because, the tools I've been working with, most of them were proprietary. And so at a certain point, right, you hit the source code, you can't edit it. And then I watched the video that Mustafa put up of just him using Ladybug Tools, which he had just released like 6 months earlier. And I saw all the things that he was doing, all the like freedom and flexibility, and like, that everything was out in the open down to the source code. And I just thought like, this is definitely what I want to be using, for the rest, for the foreseeable like future of my career. And amazingly, like, a few days after I watched Mustafa's video, I heard that he was going to be moving over to Thornton Tomasetti, where I had a summer internship at that time. And I was like, oh my gosh, like this is great. And and when he finally got there, we met, we had many a conversation, and even though that was only like, just one summer internship I had here, honestly, actually, it was probably only, those are the only like 2 or 3 months that like Mustafa and I lived in the same city. But like, that's all that was needed. And from that point on, I started contributing to Ladybug, and within a year or two, I was close to half the code, or maybe like 40% of the code was stuff that I had contributed. And Mustafa and I were great friends from that point on. So we applied to several grants initially. And Mustafa, like as I said, was the first one who just quit his former job and started to try to work full time on this. And initially we were just thinking to maybe if we can get one of these grants, like at least Mustafa will be supported. But we managed to get all the three that we applied for, including the biggest one, which was this grant from the Department of Energy. And so that's allowed us, like, we're okay for another like year or two at this point, thanks to that grant. And we're able to do this full revision of the software and to build certain services now that we can, offer off of the software. So while the software is always like free and open source and we're committed to that, we'll start to sell some services around it so that we can support ourselves in the long term. But like, I think what a lot of people don't talk about, a lot of software developers in particular don't talk about, is that like learning to code, it's a traumatic experience. I mean, there's a lot of like, especially as you're trying to apply it. Maybe if I'm to draw an analogy, and maybe this is not actually that far from an analogy, it's a bit like trying to fight a really tough video game boss, where you try and you try and you try and you try to figure out this problem in your code, and you just can't put it together, and you can get very frustrated, and there's like a trauma associated with that. But I think what happens is that all of us people who make it through and become software developers, we only remember that last part where we put down the controller, we came back next day, and then we beat them on the first go. Like, you just remember that triumph of implementing, the software. And so we don't talk about how difficult and challenging it was to learn it in the first place. So, but I can assure you that, like, those of you who are learning to code, who may be listening to this, like, the most important thing is just to keep sticking with it and to not give up. And it can be tough when you're frustrated by a certain problem that you're trying to solve with it. But if you pull through, you'll be a software developer. You'll get there as long as you keep trying.
Mm-hmm.
If anyone is learning how to code and listening to this, I would really recommend, like, you really need 3 things to learn how to code. You need some sort of reference, like, whether it's like I binged watched like a 48-hour video series for my reference, or some people like books and stuff. You need one of those. You need projects, though, to apply it to. If you're not applying that knowledge, it'll slip through your fingers very fast. So you really need to be applying it. But invariably, when you're applying it, you're going to get stuck, and you're not going to know what to do. So it's very important that you also have a community, as you said, the last part, to be able to ask your questions to. And thankfully, I mean, probably more so than a lot of other disciplines, there's like software development has really made use of the internet to disseminate knowledge. So there are great communities. I mean, things like Stack Overflow and like, all these places that are just powerhouses for answering questions. And we try to adopt that philosophy too with Ladybug Tools, that we have a forum where, we direct everybody to ask their questions and we all share knowledge on there, so that, if someone gets stuck, they can search, and probably even just a Google search will return something from our forums and people can continue that way. So yeah, so having a community is very important, but particularly for software development, your community can be literally the earth, thanks to the technology of the internet and through platforms like Stack Overflow and Google and all the other things that you can use at your disposal to search for questions when you get stuck.
Mm-hmm. And
Definitely build on other people's work, or at least research other people's work before you try and build something yourself. There's probably software that's going to be more geared, I think, towards owners or developers or some of the other stakeholders involved in the process of creating buildings. I mean, I know of a lot of startups actually right now that are really trying to gear themselves towards being more amenable to people who may not have a design background or may, or may not, have invested time to learn CAD software, but they still want to just mock up something to show. So I think software in that realm is probably going to become much more commonplace. And I think maybe specifically say with Ladybug Tools, like we're trying to do a lot, especially now that we have the core of our software divorced from any particular CAD environment, that we're trying to make it at least very easy for those experts running the simulations to share not just like a single visual with their clients and the other stakeholders in the building process, but just actually share whole interfaces and dashboards so that that those owners and other stakeholders can actually look through the data and make their own conclusions and actually appreciate the vast amount of work that went into some of these simulations. So yeah, I think, if I had to say a general category of software that I think is going to be more commonplace, it's probably stuff that's going to engage clients and owners and other stakeholders.
mm-hmm. And
Like I witnessed like hype cycles in AEC with like optimization. Like there's a lot of excitement about optimization at first, and then you build your first Galapagos model and you realize like it took 3 hours to solve a problem, design question that I probably could have answered in a few minutes by building a simpler model. But over time I realized optimization or genetic algorithms are good for maybe just these small set of things that I apply them on right now. But yeah, I think like artificial intelligence is going through the same thing. I think we're still kind of at the peak of the hype cycle, and we got a long ways to go till we realize all the useful ways that we want to apply it. And I think especially I see a lot of people right now trying to use artificial intelligence to increase speed. And I don't know. I mean, there may be some applications in that end up proving useful, but I feel like the biggest benefit that AI can really give isn't necessarily increasing like speed of simulations or trying to necessarily, really predict, like, let's say, so that you don't have to run a whole energy model to estimate your energy use. I mean, because it's very much more valuable to know that the numbers you got were derived from physics and to be able to know those with solidity than just if you need something quick, you can do a simplified version of those numbers, maybe is what I would say. Rather, I think probably the real areas where like artificial intelligence could be a really big help is like, is the excellent applications we see of it now, like, Amazon suggesting like customers who bought this one also bought that one, right? There probably are ways that could be integrated into some types of software. I think where, you say like, you ran a building like this before, here are 5 other buildings that, were kind of like that. Maybe you want to use them to look at them in order to set your assumptions for the current model that you're building or something like that. Like those types of applications, or, in search queries, like the way Google uses it, those are obviously amazing applications of it. So I think if we could find ways maybe to gear ourselves more towards those applications, maybe rather than just purely using them to increase the speed of stuff that we already do, I feel like we'll get to that plateau of productivity a little faster.
mm-hmm.
The trend that I see like almost all software projects follow, like what we're undergoing now with Ladybug Tools of like totally revising the software and like making it, like almost 90% of the code is independent of like any particular operating system or CAD environment. Like this process of like pulling out the core and making it its own like thing. This is what I see happening all over the place. I mean, I know like McNeil just finished this with Rhino, that they pulled out a lot of their core so that they can offer like Rhino inside. I guess, and actually a lot of this maybe maybe a lot of that is a precursor to more software as a service, right? That people want to try and take the, what was traditionally just a desktop application, put it on a cloud service, and and offer access to it or access to certain capabilities to it through that. So that's probably that's definitely an increasing trend these days of things moving towards software as a service and moving, trying to divorce, I guess, the things that run all the simulations or do all the hard work, put that on a server as opposed to having everyone's computer needing those capabilities.
Mm-hmm.
Just making sure you have a reference that you can always go back to understand the fundamentals of coding or whatever you're working on. Making sure that you are applying it, to some projects, that you have some projects that you really want to, and goals that you want to tackle. And then just making sure you have a community to ask your questions to. As long as you have those three things and you don't give up, right? I mean, and as I said, it's very easy to get frustrated at some points in the process. But as long as you don't give up, you keep those three things there to help you, you'll get through. Yeah. So my advice would be, if you are engaging in this area of trying to straddle the line between architecture and environmental science or environmental design or building science, just don't be afraid. You are on the right side of history. Yeah, so maybe I can just briefly describe the hype cycle that I went through with optimization, and I think Mustafa kind of went through as well, which is, I mean, at first, we were all very excited about the prospect of optimization. I remember, I think I built my first Galapagos model. It was just looking at the optimal depth of an overhang for a simple single zone energy model. And I remember, I ran through, started the Galapagos simulation. It took 2 hours to run. And then the optimal result was this overhang that was 5 meters deep. And I just oh wow, that's that's really not what I was hoping to get out of this. And and I mean, the reality is that I guess what I learned over time is that one optimal solution isn't necessarily the most useful thing for the design process, because obviously, I mean, even if that 5 meter overhang was the best thing for the energy use of the building, it's obviously not, it wasn't something that was going to get built on this project. So a much better way to try and tackle this type of problem, we kind of realized over time, was by, I guess, instead of trying to find the one optimal solution, let's just run a range of different options and see what the trade-offs are. Let's see how bad it is if we make it this short versus that short. And I guess the kind of, if there's a term for this, this kind of visualization of all the options, I call it design space visualization, as opposed to just optimization. Other people call it brute force, because you're kind of just running through everything, instead of just trying to find that one optimal solution. But just running those types of studies ended up being much more useful for design, because I could say all right, if we make the overhang 1 meter deep, we still get 90% of the energy benefit, right? And so, I didn't need to go to a client and explain to them that they should make a 5 meter deep overhang and stuff like that, right? They're invariably, the world is going to be more complex than the optimization simulations we can set up. And so recognizing that in the way that you put together your simulations can really help pay off and just help you make better decisions in the long run.
Mm-hmm.
Maybe one other thing just to say, if with regards to learning programming languages, is that you'll usually find most of the value of computer languages are actually, it's not necessarily in the language itself, but in all these the ecosystem of other packages and bits of software that people have made, or rather what people call SDKs, or I guess in Python we call them packages, or APIs, some people call them. But make sure do your research to see if someone else has put together a package or an SDK or API for something, if you want to learn that and build off their work.